So you had a quiz Monday.
Monday quiz, guys.
We're talking about liquids here in this section. So focus, no screwing around, so we can kind of use our time wisely here. Here is your theory for liquids, and most of this should make sense. Are liquids touching?
Yeah.
Yep, okay. They're very close to each other, like solids, except for solids are rigid and they are locked in place, and liquids are not locked in place, which allows them to be a fluid or flow. And that's essentially, you know, my famous example of a solid can only kind of vibrate, but liquids have the ability to flow. They're still in contact with each other, but they have the ability to flow. 3, they are not easily compressed, and they're not going to expand much. And then 4, permeability. They do have the ability to flow, so they are permeable. Ooh.
Wow.
Nice.
What? Wow. What?
Almost. This is a full glass of water. I almost spilled it all.
I've learned about water.
Yeah. Okay. So permeability and diffuse, because of their ability to flow, they can do those as well. So this is a little bit new here for you. You've probably heard the word cohesive or the word adhesive. Yes?
Yes.
Yeah.
Okay. Where do you typically hear adhesive the most?
Blue.
Tape.
I would think tape.
Okay.
Adhesive tape.
Band-aids.
Okay. So now notice it says these are what?
Forces.
They're effects of intermolecular attraction. So we're talking about effects on dispersion, effects on hydrogen bonding, and effects of dipole-dipole. Now, this is a really, really summarized version of cohesion. You maybe want to write this next to it, or write something next to it that says that when it says attraction between particles, it's talking about of the same particle. So it would be your natural. You got your partial negative here, partial positive there. So it is the attraction between like particles. So this intermolecular force, that's a cohesive force. So you're probably wondering, well, what's adhesive? It still deals with intermolecular forces, but an example of an adhesive force would be if water was attracted, its intermolecular forces were being attracted to some other particle's intermolecular forces. Does that make sense? Okay? So that's why tape is called it's called adhesive tape, because the intermolecular forces in tape, when I put it on something else, that is an adhesive attraction. The intermolecular forces of tape are being attracted to the intermolecular forces on the table, or your face, or you name it. Does that make sense? Okay? So it's really important that, I know this is a really summarized version of this, okay? But this is going to be the attractive forces between here, right? Everybody see that? What we've been talking about the past 3-4 days? Okay? Adhesive is still an intermolecular attraction, but it's an intermolecular attraction between water molecule and some other substance, or a water molecule and like the glass that you're drinking out of. Okay? Does that make sense? We're going to talk about effects of cohesion, and we're going to talk about effects of adhesion. What? Yeah. Really?
I saw you take the hat off.
It's like all you need is the last sentence.
Okay. I'll just quickly restate that. I know it's kind of awkward. All right. Cohesion. What was our typical? Guys, cohesion is our typical intermolecular force attraction. Right. This is I've been showing you this. Right.
Where'd the mouse come from?
Stop.
What's going on?
Okay. This specific attraction is water molecule to a water molecule. Attraction between like particles is called cohesion. Okay? A water molecule attracted to intermolecular forces of some other substance is an adhesive attraction. Okay? So you see how they're both intermolecular attractions. One is between the same particle, other is a particle being attracted to a different kind of particle.
So how does like glue work? Is it just?
No, ground trail.
No, this is like.
I don't know.
I was thinking about
The molecules in glue bond to the molecules of other substances.
I don't think it's a bond.
I think what it is.
And here,
is it's like a quick hardening substance, so it'll go into the cracks and pores of the substance, and then solidify. So it's just like a solid, but it's in the pores.
magic boys.
Surface tension is a type of cohesive force. It's water being attracted to water that causes surface tension.
Oh, I love this one.
Okay? It's called the tightening of a surface of a liquid due to an unbalanced and intermolecular force. And I have a little visual that will help show this. Okay? This is why droplets of water will form a sphere, because a sphere has the least amount of surface area available, and that's what the surface tension is going to do, because you have an unbalance of forces. And I have a visual on the next slide which will help you kind of see this, because most of the time when you don't really kind of see what's going on. Well, at the surface, like all these water molecules are attracted to other water molecules via intermolecular forces. That make sense?
Yeah.
Okay? Well, like this water molecule is attracted to this water molecule, and Newton's third law says there's an equal and opposite force, correct? Okay, well at the surface, you have this water molecule pulling down on, or this water molecule pulling down, or pushing up on this one, and this one pushing down on this one. But notice how there isn't a force that's opposing this upward force. Everybody see that? Okay, so you have everything balanced except for there's nothing pushing down to balance out this upward force. Everybody see that? Okay? And what ends up happening then is, if you have an object that's light enough to sit on the top of the water that this force can hold up, it won't break through what's called the surface tension. And you guys probably seen this, but
Is there any liquid that doesn't want to be how they
Are we gonna go?
yeah, you can come over here.
What was the experiment you did where you crushed a can?
What was that? That was pressure.
Big pressure.
How
How did you do that?
Okay,
You heat up the water molecules and then.
So, because of the unbalance of forces pushing up, it will have enough force to hold a paper clip, or some other examples. I always make this joke. It's not really that funny, but Jesus, when he walked on water, did he reduce his weight to nothing, or did he increase the force pushing up of the water molecules?
Oh.
You just said that's a joke.
That's a joke
Well-
or a statement or a question?
It probably is neither. He's just God. I don't know if that's actually you know what I mean.
Wait, can you do this on a penny? Wait, push down on it a little bit.
Now I want to show you, because if I take and I push down, you can actually see the surface tension bulge. So if I go like this, everybody see the
Oh, it's so
bulging,
cool.
and then I can break it. See that?
Oh my god.
Everybody see a little snap and
Yes.
Yeah, that's a.
It's like it's
so I can push, and it bulges, and then as soon as I break it,
wow.
it like causes it to go all the way through. So if I apply enough force to go over that upward force, you can break that tension, and then I can actually go.
Wait. Oh no, that's so sad. Kramer, no. Do you have any pennies?
Because the
Oh,
paper.
Alright. A penny is not why.
I've seen it. We've done it with a penny
Yeah.
before.
So what it's going to do is it's going to cause it to be a sphere. That's why it bulges versus like running down the edge.
Do
It
it
also
with
has to do with a couple other
Wait,
things.
do it here. Try a dime. It's lighter. Wait, try
I
this.
don't
This
think
is
it'll
light.
work.
This will.
Nice.
You just lost.
Nice.
We've done.
I only lost
Will
one.
this float? Hey, look, it
Well,
floats.
that's not necessarily. How did you do the can?
I can explain that in class. I want to get through this. Okay, so it's hard to see this, so maybe I'll shut this off. If you want to get your nickel or quarter or whatever.
Oh, is that a water bug?
Oh,
You can actually see the bulging indents of the water bug.
Those are cool.
Okay? And have you ever heard of those, what are those animals that can run on water?
Oh,
The dinosaur.
whatever they're called. So the
Yeah,
reason why they can do it is because, for one, they don't weigh a lot. For two, they're moving so fast that the force is reduced enough that they can walk on water.
Maybe
Hey,
you
here's
can
a little
just
video.
running really fast.
We don't have time. That's 12 minutes. Okay.
Surfactant.
Surfactant. Anybody know what a surfactant is?
Sounds like those like.
You use it every day. Otherwise, you're gross if you don't.
Deodorant.
That's a good guess.
So,
Soap.
Detergent.
Surfactant is soap or detergent-like stuff would be another example. Okay? What's interesting is if I put soap in there, it wouldn't be able to hold the paperclip anymore.
Because it's got other stuff in between these,
Good,
right?
so what it does is it reduces that surface tension force. Yeah. Yes?
You take some water and put it on a plate, and then pour some pepper on it, and then take your finger with
Soap.
soap on it, and put it
Yep.
in the middle, like dispersions all.
Yep.
Yeah.
Yep. You guys all probably seen that. You ever done
Put
that
the
with milk and food coloring?
We did
Yeah.
that in biology.
Yep.
how about
Now they watch much.
Put that away from
No,
me
we're gonna see-
now. Okay, so what this does, and what I think this is cool. I don't know why it says how Play-Doh works. I use this to show how soap works. Okay, so this is a soap molecule. What's really interesting is you have what's called a hydrophilic end and a lipophilic, which simply means one part is attracted to the water and the other side of it is attracted to nonpolar things. Okay, so you have a polar end and a nonpolar end. And you'll learn later that like attracts like when it comes to polarity. Polar things attract polar things, and nonpolar things attract other nonpolar things. Well, your dirt, your grime, and your nastiness that you have on your hands, that's nonpolar. Okay? And so water is polar. Water itself will not take that off your body because it's not attracted to the grime and the dust and the nasty dirt that's on your body. Because water is polar and that's nonpolar. They do not attract. So what soap is soap has an end that's attracted, that's nonpolar and will attract to the nasty stuff on your body. And it'll go in and it'll grab the nasty stuff on your body. And then the other part that's attracted to water is why you can wash it down.
That's so neat.
So it has to also be, because it wouldn't make sense to have soap just be attracted to grime and not be attracted to water, because it'd just be adding more stuff onto you and not being able to wash away with the water.
What does that have to do with Play-Doh?
I have no idea.
Well, is grease like not attracted to water? Is that
Yeah.
why it doesn't come off?
Yep.
what about that stuff you put on shoes that like, have you seen it? Like where
The never
Where it repels the water and
It
you just like
repels everything.
pour anything on it.
You
It's
should
like,
watch
Yeah, that's
that
good. That's how,
before.
guys, this is how wax works when you put wax in your car. Wax is nonpolar, so a water droplet will hit it and it won't be attracted to it, so it'll beat up and just roll right up.
Is there something you can put on your car windshield where it just like makes everything roll off?
Yeah, it's called Red-X.
Yeah.
Okay, here's another type of cohesive effect. Okay, viscosity. I've talked about this. It really is the ability of a liquid to resist flowing, and it's called a cohesive effect for that reason. It's so attracted to itself and not attracted to other things that it won't flow.
gauge brother.
That makes sense? This is why it's a cohesive effect. Cohesive is attracted of one thing to the same type of thing. So something like honey is really attracted to itself and not attracted to other things that it won't flow. In order for things to flow on something else, it has to be attracted to it. Okay?
Wait, so if
Molasses
it's
is-
wait.
Molasses has a really strong attraction to itself. That's why it just sticks together and doesn't want to move.
Wait, I have a question. Okay, so if honey is like super attracted to itself, why is it so sticky compared to other things?
Good question. I don't have an answer.
That's
So
how
maybe
we
because
heat it
there's so
up.
much sugar on it. That it just,
It becomes more liquidy.
Yeah.
Well, even when it's not
Everything
heated up,
party,
you
by the
touch
way.
it.
That's what I'm just saying. As temperature rises, the viscosity decreases.
Yeah, so if you like heat up honey, if you heat up syrup, what happens is you're breaking some of those intermolecular forces and allowing it to flow better. Is what you're doing when you heat up the temperature. Okay? So,
Peanut butter.
alright guys, I can't even bring up anything that's food related.
Oh no, that one I'm in here.
So, far left or far right, which one's more
The
viscous?
one on the right.
Alright. Yes.
It looks kind of gross. It's like ice.
Stop. So which one has the stronger cohesive attraction or intermolecular attraction to itself?
The one on the right.
The one on the right.
I have a
I
question.
like how it goes from like.
Why are they all the
really
same
viscous to
color?
just
What do you think they are made
gel.
of?
All right, adhesive. So now those first three, those were three cohesive effects, things attracted to themselves. These next five are adhesive effects, where you have a particle attracted to some other particle, but it's still, the attraction is still a what attraction?
Intermolecular.
Intermolecular force attraction. Okay, does that make sense, everybody? We're still talking about intermolecular forces being attracted to other intermolecular forces. I was not prepared very well for today.
Just remember, while you get this ready, can I ask you a question?
I heard.
What? What?
While you get that ready, can I ask you a question?
Sure.
So my dad, I think they're all out of white fluid or something, but my dad decided to make his own, and he had looked it up, and it's ammonia plus dish soap plus water. Put it in my car. This morning, I flicked it, because my windshield's been really dirty because it's been out, and it like instantly froze onto my windshield. And it was like snow, I could like barely see.
That's why they make actual windshield wiper fluid that's designed to like be in winter. So mine, when I put in mine, is like negative up to -20, won't freeze.
Yeah, that's the advantage of that.
It's okay, Ryan.
Yeah, it will happen with regular
Is that just because it froze, or is it because like,
Yeah.
because it like came out like liquid and then it's like more windshield?
Yeah, it's warm coming out, and then it hits your windshield, which is cold, and the wind hitting your windshield, which is also cold.
I waited
Okay.
till I got in the parking lot till my car warmed up to do it again, and it didn't come out at all.
Didn't come out at all.
Probably froze inside of it.
I think your dad messed that one up.
But in the back it works. Totally fine. It doesn't freeze or anything.
Okay. I don't know. Malfunction error.
Nice.
Okay. So I've shown you meniscus before, I believe.
Yes.
If you look at water in a small little tube here, you can actually see it will curve upward. And I will pass this around.
That's the surface tension of the solid.
So here's what happens. It has nothing to do with surface tension, actually.
You keep the marker.
The traction to the side of the tube.
Yes.
That's all that for.
Okay, so while you're passing it around, please make sure you're still paying attention. So here's your test tube. What you have is your meniscus, is the water, as you look at it, actually kind of curves upward. Okay? And the reason why that is because water has attractive forces, and the glass tube has intermolecular forces that it is also attracted to. So it will rise a little bit because it's attracted to it. For example, this is why paper towels can soak up water. It's because paper towels are made of a material that's attracted to the polar water molecules.
So why if you like put a paper towel in that, it would go higher than the water?
Wait, so
Like
why?
Towel on what?
Like if you put it in I don't know, like a bowl or a cup or something full of water, the water on the paper towel will go higher than the surface of the water.
I'm not
Like if you
familiar
put the
with
paper towel in the water will like creep up under the paper
that.
towel.
Oh yeah, it will rise up the paper towel. Yeah, absolutely.
Can you
Yep.
explain like why if you like try to put a dry paper towel on the wall, it will not stick, it will fall, but then if you get it wet and on the wall, it sticks.
It's probably because the water is attracted in the paper towel is a strong enough attraction with the wall, it'll stick.
You
Yeah.
telling me that everything is because of forces?
And attraction?
Yeah, there's a lot of forces in this world. Okay, now if this were if this were
Use the force.
now listen, if this were Mercury, this is what it would look like. And the reason why is because Mercury has such a strong attraction to itself and not very attracted to the walls of the container that it actually will do the surface tension idea.
Could we drink that?
Is that why
Don't you have some?
Let's
when you
do
have
it.
Yeah, we don't have time.
mercury on its surface and you can just roll it around?
Yeah,
Mercury's
I've got
very
some.
poisonous.
If we have time, I'll show it to you.
We should make some.
I want to talk about this one because this one's kind of cool. This is actually how plants work. Part of like one thing that's really important that allows plants to actually function.
Xylem in the flow.
It's called capillary action. So the test tube is sort of narrow, but we're talking about a really narrow tube. There's things called capillary tubes. I don't own any of them. But what happens is they're narrow enough that water will completely just rise up the tube because it's attracted to the walls of the tube.
Oh yeah.
Wait, isn't that something in the heart capillary?
So this is how plants. You ever wondered how plants get water from the roots up to the leaves?
Tubes.
It's because of this idea. The stem acts like a capillary tube, has small little tubes in it. No, it's not probably a tube, but it's same. It's used the same way or done the same way, and so water actually just rises right up it, right to all the leaves, all the parts of the plant that needs water. Because of adhesive effects, water being attracted to whatever it is that it's rising up in a particular plant. Now, I can kind of show you a little bit of this.
Is it like when you put a straw in a cup of water?
So these are small enough holes, and also you've got a lot of contact with the surface that if I put water in this,
Oh, I know what the word was reminding me of. Catheter.
don't say that. That does not bring back fun.
What is that?
Okay. I put in water here. Is there water in there?
Yes.
Okay.
Whoa! He just turned the water upside down.
So, is there still water in there?
Yep.
Oh, sorry.
I got it done.
Still perfect.
Okay, so because the water is attracted to the walls of this, it has a strong enough force to overcome gravity pulling it down. So well, that's because some of it's not on it. But if I take and I give it a force,
Whoa!
you can get it to come out.
Where can I get one of those?
I want.
Walmart.
Okay, so now you can tell there's really not any water.
That's so cool.
It's because the water molecules are attracted to the walls of that container, and they're narrow enough that it allows it to hold it in there.
Wait, so how big is that? Like the biggest it can be for that?
I don't know.
Not really, because your water bottle thing.
But I don't know if that's what my water.
That's not.
I think it's a different force.
I don't think that's it.
Okay? So the three other adhesive effects. Did you guys know if you weren't attracted to water, you'd never get wet?
Water's not wet!
I never said water's wet.
We know.
I said water's not wet.
We know.
Okay? Because if you put water on a duck's downy feathers, it doesn't get wet.
Downy? Isn't that a
Down.
Down feathers? Whatever.
Yes,
Down.
Downy's a brand.
Downy is Downy is like tire. Detergent.
Alright, so the reason why food droplets get diffused through water is because it's attracted to the water.
Is it called detergent because detergent?
Yeah, that's okay. You wrote it. I'll just
Oh my soul!
Praise the Lord.
And it's the
Okay, permeability is an adhesive effect. Water is attracted to paper towel, so it allows it to flow through the paper towel. For example, have you ever tried to like put a paper towel on honey or syrup? So it doesn't like suck it up, does it?
Sticks, dude. Big towel with
So it does stick. That's weird to me. I'm not 100% sure.
Is the homework still due? Because
You did stop me.
Well, like, I
Cole,